Hi, everyone. Thank you all for joining the Bullitt History of Medicine Club today. My name is Lorena Milo, and I'm a second-year medical student at UNC. I'm really excited to be introducing today's speaker, my classmate, Elizabeth Salisbury. Elizabeth is a current MS2 at UNC School of Medicine. She graduated from Williams College in 2018 with a BA in biology and a concentration in science and technology studies. After graduating from Williams, she worked in an infectious disease lab at the University of Massachusetts School of Medicine, where she explored innate immunity and its role in combating disease. She has always been interested in how we classify diseases, as well as the role of the pharmaceutical industry and vaccinations. When she graduates medical school, she hopes to pursue a career in infectious diseases. Her talk today investigates the origins of the anti-vaccination movement. After her presentation, we will be opening up the session to Q&A, so please submit any questions you have for Elizabeth in the Q&A box. Thank you.
Awesome. Well, thank you all so much for being here today. This has truly exceeded and terrified my expectations that you all are here. But it means a lot to me that everybody is willing to listen to me ramble for an hour on the history of the anti-vaccine movement. So I wanted to start this talk first, if it will, here we go, with a bit of a disclaimer. This talk is not going to be a condemnation of the anti-vaccine movement. I fully believe in vaccines, and I believe that they are a medical miracle in many ways that have fundamentally changed our society. But in terms of the anti-vaccine movement, I think that it's really important to investigate the origins of the movement so that we can have better conversations with our patients. Because vaccine hesitant parents aren't crazy. Injecting yourself or your child with a pathogen, a virus, or a bacteria that you know causes sometimes a really severe disease is not a natural thing at all. And all you have to go on that this vaccination is going to help instead of hurt you and your child is the trust that you have in the medical community, in your doctors, and in scientists. And so as medical providers or future medical providers, it's our job to help build that trust. And so I'm hoping that this talk will give you a couple more tools in your tool belt to have more productive conversations about vaccination with some more vaccine hesitant parents and patients. So to talk about anti-vaccination, we first have to talk about vaccination and the origins of vaccination. Disease has been a constant bane of humanity's existence since the beginning of time, but we are really, really smart as a species. Our ancestors observed that people who got smallpox and got better didn't get the disease again. And so armed with this knowledge, the idea of variolation was born. So variolation as a process is when you take an active, pussing, really gross smallpox scab from an actively infected person with smallpox, kind of dry it out in the sun, you ground it up, and that's sort of a very rudimentary form of attenuation. And then you put it into someone else's body. And so that most of the time will give somebody a much milder form of smallpox while at the same time allowing them to build up immunity to future smallpox infections. So this process of variolation, which is also known as inoculation, has been discovered multiple different times throughout human history. In China around AD, somewhere in this like 500-year range of AD 590 to 1000, they used nasal inoculation. So they inhaled those ground up smallpox scabs that I was talking about. And this actually rose to prominence a lot in the 1500s when the emperor inoculated both his entire army and his children. In India, they used cutaneous inoculation, which is the form that we're most familiar with today, where the scabs were placed in an open wound that was created usually on someone's arm or leg. This spread to Egypt and throughout Africa as well. And with increasing trade units, with increasing trade to Europe and the Americas, it spread there. And so it was a very controversial procedure when it arrived in Europe. It's important to remember that the physicians who originally were against it were also the physicians who were very into leeches and bloodletting at the time. So we do want to take some of their scientific knowledge with a grain of salt, but this was something new and it was scary. And so a lot of physicians said like, no, thank you, I'm not interested. However, the aristocracy in Britain, especially this woman named Lady Montagu, played a really big role in advocating for the use of inoculation as a way to protect people against smallpox. Additionally, in America, the idea of variolation was brought there by African slaves. And so it's unknown the exact origins of the process of variolation in Africa, but a lot of the slaves who came to the colonies had variolation scars on their arms. And so Reverend Cotton Mather, who is the Reverend Cotton Mather from the Salem Witch Trial, so he's making like a brief appearance in our anti-vaccine world here. He owned slaves, and those slaves had variolation scars, and they taught him about the process of variolation and how it protected you against smallpox. And so as a reverend, he became a very unexpected advocate for variolation in the colonies. The religious arguments we usually hear both in the past and too often today against vaccination is that it's against God's will, it's interfering with God's plan. But Mathers had a very different view of vaccination or of variolation at this time. His argument was that only a kind and merciful God could have invented something as miraculous as this procedure to stop disease. And so he was a really big advocate for variolation in the colonies, especially in 1721 when Boston was suffering its own smallpox epidemic. And that's not to say he didn't face enormous opposition. He certainly did. Physicians in the American colonies were initially against variolation as well. I think it's important to note here that while variolation did have a 0.5 to 2% mortality rate, smallpox had a case fatality rate of 20 to 60%. And so it was undeniable that this procedure saved lives. However, in the age of smallpox, people dying of smallpox was a really common thing that was a part of life. However, with variolation, even though you could save a lot of lives, this was a procedure that you were doing to somebody who was otherwise healthy that had a 0.52% chance of killing them. And so that was a risk that a lot of physicians were really, really scared to take on. But despite the controversy, the benefits of inoculation were undeniable, and advocates in the colonies, including Benjamin Franklin and George Washington, spread the procedure a lot. So as we previously touched on, the 0.5 to 2% mortality rate is certainly nothing to laugh about. That was a very real risk of variolation. A couple other risks that were pretty serious to consider is that when you inoculated yourself with these smallpox scabs, even though you had a much more minor infection, you were still fully contagious of smallpox, and you could give people around you a full-blown case of smallpox at a 20 to 60% mortality rate. And so that was a very real thing that happened. Just because you were protected, the people around you were actually worse off because you were contagious. Additionally, this was body materials that was taken from one person and passed to another person. And so with the spread of smallpox that way, you could also spread other bloodborne diseases like syphilis. And so contamination of the pus and infection of the individuals around you, in addition to the mortality rate, made variolation, while a big improvement to being naturally infected with smallpox, a imperfect procedure. And so this brings us to the invention of the first vaccine. So in 1796, Jenner discovered the smallpox vaccine. And I do use the word discover here a little loosely because the use of cowpox to protect people against smallpox had actually been used a couple of times throughout human history, including like about a decade ago in England by a nearby farmer. But history has awarded Jenner the credit with discovering the smallpox vaccine. And this talk isn't about Jenner, it's about vaccination. So just gonna move along, but note that there is a little bit of an asterisk to that. And so Jenner, for all intents and purposes, discovered the smallpox vaccine by observing that milkmaids who had contracted cowpox, they never became infected with smallpox. And so he subsequently experimented on the people in his community by doing a pretty similar procedure to variolation, where he took pus, dried it, ground it up, and then put it in a cut in someone's arm, except for he took the pus from cowpox pustules from cows and ground that up and put it in people's arms. And then 2 to 3 weeks later, he actively exposed these participants to a full-blown smallpox infection. So a couple of things about this wouldn't really fly today, but thankfully the results worked in Jenner's favor. And he was really, really excited about the success of these experiments. He submitted his results to the Royal Society of London, but the Royal Society of London wasn't quite as enthused. So Jenner made this discovery before germ theory existed. So he couldn't explain really what smallpox was or why his vaccine worked the way it did, but he just knew that it worked. And the Royal Society wasn't really interested in that, and so his paper was rejected. However, not to be deterred, Jenner self-published his paper in 1798, and with the help of some physicians in London who are a little more favorable to the idea of vaccination, it spread really rapidly, reaching the United States in 1801. So as more and more people were vaccinated against smallpox, the advantages of vaccination versus variolation became incredibly apparent. Cowpox, even in its most virulent form, is a much more mild disease than smallpox, and so fewer people died as a result of vaccination, and the reaction was far less severe. Additionally, people were inoculated with cowpox and not smallpox, and so they couldn't infect those around them with smallpox because that wasn't the disease that they had. So before I move on, I'd like to just take a quick minute to clarify some vocabulary here, because I know vaccination, variolation, and inoculation can kind of blend together a little bit. So when I say variolation, I'm referring to the pre-Jenner inoculation of a patient with smallpox pus from one person to another person. So a very rudimentary vaccine. Inoculation is kind of a catch-all term. So that's like anytime you're using a disease or part of a disease or part of a pathogen in a treatment or procedure to protect yourself from that disease. And so vaccinations are inoculations. And then I'm going to use the word vaccine from here on out because thanks to Louis Pasteur, who named the rabies vaccine in honor of Jenner, that name's kind of stuck around. And so it's just a lot easier to use that term. So with that, vaccination proved to be incredibly advantageous, as I previously stated. Less people were dying, people weren't getting randomly infected with smallpox anymore because of variolation, so this was really, really great. And in 1840, variolation was actually outlawed in England because vaccination was such an improvement. And in the subsequent years, vaccination progressed from being strongly encouraged to mandated. Resistance to inoculation has already been present. As I said in my disclaimer, intentionally infecting yourself with a substance in the name of protecting yourself against that substance is an inherently unnatural thing, especially in an age before germ theory. People were pretty hesitant about it. But before vaccination was mandated, there was no need for an organized resistance. So as vaccine requirements became increasingly organized, so too did the anti-vaccine movement. The same year that the smallpox vaccine became mandatory in England, which was 1840, the first anti-vaccine society was founded, and it was called the Anti-Vaccination League of London. And this league's core values were that they were fundamentally opposed to mandatory vaccination, and they were also questioning the safety and efficacy of the smallpox vaccine. As I said before, the smallpox vaccine entered a pre-germ theory world. People had no idea how smallpox was spread. They had a lot of really good guesses or how the smallpox vaccine worked, but there were a lot of theories that went around about the vaccine and a lot of rumors. Not all of them were positive. So claims that smallpox vaccine actually caused smallpox and didn't prevent smallpox were really popular among anti-vaccinationists. Additionally, the idea that improved hygiene and sanitation was responsible for the decreasing smallpox rates instead of the vaccine itself was a popular alternative theory to germ theory. The religious argument of disease as a punishment from God was also pretty widespread as well. So there was a lack of scientific consensus on exactly what smallpox was and how it was transmitted, and within that lack of a consensus, anti-vaccination thrived. The movement was convinced that the smallpox vaccine was not just ineffective but dangerous, and that mandating this vaccine was a fundamental violation of an individual's right and autonomy to decide what to do with their bodies. Anti-vaccination societies in the 1800s laid the foundation for the modern anti-vaccine movement. While the specific arguments have changed somewhat, the core tenets are remarkably consistent. So after that incredibly long introduction, for the remainder of this talk, I'm going to explore the resistance to mandatory vaccination, where we are with that today, as well as the evolution of safety and efficacy arguments. And while I'm exploring the evolution of the anti-vaccine movement, I'm also going to touch on key events in the development of vaccines that have contributed to or fueled the movement in different ways. So government has long recognized and embraced the benefits of vaccination. Justification for vaccination and for mandatory vaccination can be boiled down to a single concept, that vaccination is the responsibility of all citizens to create a healthier society, even if it contradicts what's best for you as an individual at times. But it's become abundantly clear during this pandemic that people are often pretty selfish. Being selfish isn't always a bad thing. It's often embedded into our DNA to ensure the survival of our genes and our offspring's genes. But vaccination at its core is a fundamentally unselfish act. Yes, there is an incredible benefit to you in protecting yourself from disease, but even though the risk is very small, vaccination is not risk-free, and it greatly benefits those around you, especially those who cannot be vaccinated. So early arguments against vaccination pushed against this idea of civil responsibility. They argued that vaccination was a personal decision and that the government had no right to interfere in it. Even if vaccines were risk-free, which they certainly were not in the 1800s, anti-vaccinationists would have still argued that mandatory vaccination was unethical on the grounds of government encroachment into personal affairs. So mandatory vaccination in the United States throughout history and today currently encompasses two spheres, the military and education. Mandatory vaccination has a very long history in the military, whose utilitarian motives and strict sense of order and hierarchy foster obedience and prioritize the group naturally over the individual. Mandatory vaccination was first used in the United States actually before vaccination technically existed. During the Revolutionary War, the British Army used variolated civilians as biological weapons against the American troops. So they sent these variolated citizens, who I remind you were actively infectious with smallpox, they sent them into the camps of the American troops, and 5,000 of the 10,000 troops of the American troops in Quebec became infected with smallpox. And so after this, George Washington was like, this is unacceptable. We have to do something about this. And so he ordered that all soldiers who had not already been infected with smallpox, he ordered that they be inoculated against smallpox. Today, vaccination is a fundamental tool in the success of any military. It insulates soldiers against the poor hygiene and close living quarters that far too often accompany military life. Just to sort of demonstrate the progression of science and medicine, how it's helped in the military, we're going to take a look at a couple wars and the death rates associated with each war. So in the Spanish-American War, which was 1898, for every one person that died in combat, you had 13 people who were dying of disease. And then when you reach World War I, that number dropped pretty drastically. For every one person dying in combat, you had one person dying of disease. But then World War II, for every 87 people dying in combat, you only had one person die of disease. And so vaccination, of course, isn't solely responsible for these efforts. We had huge leaps in sanitation and medicine, but vaccination does play a very large role in preventing a lot of these unnecessary deaths due to disease. So vaccination has made the military as a whole healthier and more efficient, but it hasn't come without a cost. Soldiers are often viewed as parts of a whole, and parts far too often are replaceable. Soldiers have to get more vaccines than the average citizen, and sometimes these vaccines are either less tested or have more side effects than would otherwise be acceptable for civilians to endure. So just an example of this is in 1941 with the yellow fever vaccine. And so this vaccine was required for all US Armed Forces members. And it was made with human serum. And so thousands of individuals donated their blood, serum was gathered, and it was pooled to create this vaccine. And so that meant that blood from one person could end up in hundreds of thousands of vaccines. So in 1941, we knew a lot more about medicine than we did, but a lot of the diseases that were transferred by blood hadn't yet been discovered yet, and you can't screen for something that you don't know exist. And so unknowingly, serum from donors who were infected with hepatitis B ended up in the arms of thousands of military men and women. And because of this, 50,000 soldiers during World War II were hospitalized with jaundice and 100 died. It's unknown the long-term consequences of this disaster because hepatitis B does cause liver cancer. And so we don't know how many liver cancer diagnoses in World War II veterans were related to this vaccine. Despite the consequences of the yellow fever vaccine, the stats previously stated about World War II deaths compared to previous wars do demonstrate the effectiveness of vaccines and health measures. This jump ahead into our safety and efficacy discussion is not to condemn mandatory vaccination, but rather to demonstrate that vaccines are only as good as what we know and how we make them, so they're not foolproof in any way. Another sphere that is often discussed in the world of mandatory vaccination is education in schools. So in 1855, Massachusetts was the first state to mandate smallpox vaccination for all school children. And a lot of parents had a similar reaction to those in England, who they were upset about the government encroachment into their private life. And so this law was challenged in 1905 in the Supreme Court case Jacobson versus Massachusetts. Jacobson's argument was one that we've heard before in the last 30 minutes, that vaccination cannot be imposed on a healthy citizen just because they might be infected with smallpox. Individuals have a right to get sick if they want to, and denying this right is a violation of the liberty and freedom of individuals. The Supreme Court disagreed with this assessment, however. They ruled that there are instances where the good of society outweighs individual liberty, and that this is one of them. In the court ruling, they cited Massachusetts state constitution, which states that all shall be governed by certain laws of the common good, and that the government is instituted for the protection, safety, prosperity, and happiness of the people as a whole. Mandatory vaccination for school children is the primary method that the United States has chosen for mass inoculation. Listed on the PowerPoint slide here are the current vaccine requirements for North Carolina school children. These requirements do vary slightly state by state, and each state has slightly different exemption laws. All states do allow for medical exemptions, but some states also allow for religious or philosophical exemptions. In North Carolina, we have medical exemptions, and we also have religious exemptions, but we do not have an exemption for personal beliefs. However, the religious exemption only requires the parent writing a personal statement saying why they're religiously against vaccination. So it's not a difficult exemption to obtain. The spread of public education in the 20th century really allowed for mass vaccination to take hold in the United States, because all children were required to go to school and all children were required to be vaccinated to go to school. And so this sort of circular requirement has been challenged multiple times in court throughout the last century, but it's always been struck down with reference to Jacobson versus Massachusetts. There are two main arguments for mandatory vaccination for school children, and as we develop more vaccines, these arguments, the distinction between these arguments are becoming increasingly important. You have this first argument, which is the one I've been referencing to, and the one the Supreme Court has referenced to when they ruled in Jacobson versus Massachusetts, and that's the one that states that mandatory vaccination is a public health opportunity. So this is where you can kind of catch the most people at one time who need to be vaccinated. And it's really important to ensure that our population as a whole is vaccinated against as many diseases as possible. Increasingly, we're also hearing the argument that mandatory vaccination of school children is important because children should be vaccinated against communicable diseases because their daily environment facilitates the spread of disease. Now, this argument is true and it's important, but this argument can be easily manipulated to exclude certain vaccines, as I will demonstrate. Making a vaccine mandatory doesn't just ensure that people will get the vaccine, it also ensures that people have access to vaccines. So when a vaccine is mandatory, insurance is more likely to cover it, it's more widely available, and it's also often cheaper even without insurance. And so when you include a list of a vaccine on a list of mandatory vaccinations, you're often making it more available, especially for people in lower socioeconomic classes, when it would otherwise be cost prohibitive. Objection to mandatory vaccination in the 20th century was originally focused on autonomy and parental rights, and this does hold true today, but we're seeing more and more with the invention of new vaccines, a lot of parents focusing on this second argument and using it as a justification to exclude certain vaccines from the mandatory vaccination list, specifically hepatitis B and HPV vaccines. So hepatitis B, which has already briefly made an appearance in this talk, is a double-stranded DNA virus that was discovered in 1965. It's transmitted by bodily fluids, so blood and semen, so things like IV drug use, sexual intercourse, pregnancy or birth. stuff like that can spread this virus. But if a child is infected with hepatitis B and kind of walks into school, they're pretty unlikely to spread it unless they're creating like little like blood brother packs in the bathroom. So chronically, this disease does cause liver cancer. So the hepatitis B vaccine was our first anti-cancer vaccine, which I cannot emphasize enough how amazing that is. So again, it's very infectious, but it's not airborne. And so this isn't an infection that you would get just walking around a school. Public health officials argue that including hepatitis B is really, really important in the mandatory vaccinations. As children grow up and engage in riskier behaviors, they can still be protected. But many parents argue that it's unnecessary because they don't want to imagine their kids engaging in these riskier behaviors. While the hepatitis B vaccine is listed as a requirement in the North Carolina list of vaccinations, the HPV vaccine is not. It suffers from the same stigma as the hepatitis B vaccine, which is only further amplified by the almost exclusively sexual nature of its transmission, as well as its focus on causing cancer in females. And so the HPV is a sexually transmitted virus that can cause multiple types of cancer in women. And this vaccine, again, is another miraculous anti-cancer vaccine. If we mandated this vaccine, we could prevent up to 3,700 deaths from cervical cancer every year. But the arguments against the inclusion of HPVs largely center around abstinence-only education. Parents are worried that this will interfere with that education, and they don't want to explain to their children why they're getting this vaccine for a sexually transmitted virus. So without mandatory school vaccines, it's undeniable that significantly fewer people would be vaccinated. Since the invention of vaccines, people have been opposed to mandatory vaccination and have argued that it violates personal freedoms. However, the Supreme Court has consistently upheld the state's rights to violate these freedoms in the name of the greater good. But if you're going to mandate a vaccine, I personally believe you have a responsibility to make it as safe and as effective as possible. But vaccines are made by people, and as we've previously seen, people sometimes make mistakes. Through science and regulation, which has made leaps and bounds in the 20th century, these mistakes have become less frequent and less serious. But it's important to recognize that even the safest vaccine isn't 100% risk-free. Like every other procedure or drug in medicine, vaccination comes with risks. And even if that risk is as simple as a sore arm, those risks, patients deserve to have an open conversation about the risks and benefits, which are very vast, of vaccination. And so they feel like they're making a fully informed decision for themselves and for their children. At its core, the enduring arguments about safety and efficacy can be boiled down into three main points: concerns about contamination, concerns about the antigen or pathogen itself in the vaccine, and concerns about vaccine additives. Thankfully, we've mostly ruled out contamination with the use of antibiotics in vaccines, but concerns about the antigens and additives are still very prevalent today. It is important to note that as more vaccines have been created throughout the last century, the rules and regulations around vaccines have tightened and become more standardized. Today, as you can see on the screen, creating a vaccine is a very intense process with lots of checkpoints. And this is because public's trust in vaccines depends on them being safe and effective. And so this regulation wasn't put in place overnight, and it represents a century's worth of trial and error in vaccine production regulation, but it is pretty effective today in creating really good vaccines. So the first concern about safety and efficacy is contamination. As we previously touched on, smallpox variolation was a process by which you take the scab from a person to another person that was really easy to transmit bloodborne infections. Well, when you've inoculated against cowpox, you could eventually do the same thing, take a cowpox pus from a person's arm and infect the subsequent person with cowpox. And so the risks there were still the same, risks of other infections. Additionally, risks sort of associated with cowpox, well, it was much more mild, things like toxic shock, encephalitis, rash, etc. And so the smallpox vaccine was a breakthrough, but it was a very unregulated breakthrough at the time. In addition to these possible contaminations of the real smallpox vaccine, you also had the additional problem that anybody could pretend to be a doctor and say that anything was the smallpox vaccine and just inject you with it. So that's not an ideal scenario for building trust in the smallpox vaccine. And when the smallpox epidemics became more under control thanks to vaccination, people started noticing the risks of vaccination more and more. And so this prompted Congress in 1902 to pass the U.S. Biologics Control Act, which was the first regulation of vaccine production across state lines. Even with this increasing regulation, before antibiotics were added to vaccines, contamination was still a very real problem. In the early 20th century, the diphtheria antitoxin, which is a tongue twister, was discovered. And so this antitoxin was produced on literal vaccine farms. You injected horses with diphtheria, and then the antibodies sort of were grown and developed in the horses, and then you harvested these antibodies from horses and then injected them into people. And so this was a really, really effective way of producing a vaccine against diphtheria unless the horse was infected with tetanus. And so if the horse wasn't properly tested for tetanus, you could accidentally infect people with tetanus when you were trying to protect them against diphtheria. And that's exactly what happened in 1901 in St. Louis when a group of children were accidentally infected with tetanus due to a contaminated diphtheria vaccine, and 14 of them died due to lockjaw. So improper attenuation also dates back to the smallpox vaccine. Dr. Benjamin Waterhouse in Boston preemptively vaccinated all of Marblehead, Massachusetts in the late 1800s, only to have 68 die in a smallpox epidemic of his own creation. Unknowing to him, what he thought was a benign strand of cowpox ended up being a virulent strand of smallpox. Again, in 1919, you had 300 children were injected with an improperly balanced diphtheria antitoxin, and 10 of them died. By far the most famous incident of improper attenuation that still has a lasting impact today, though, is the Cutter incident in the 1950s. And in this incident, the Salk polio vaccine, its improper manufacturing resulted in the deaths of 206 cases, resulted in 260 cases of paralytic polio, which were directly linked to Salk's polio vaccine. Just to set the stage, before the Cutter incident, in the mid-20th century, the American people were desperate for a successful polio vaccine. Unlike other diseases, polio hadn't gone away with increased hygiene and sanitation and actually gotten worse. And that's because polio is transmitted via the fecal-oral route. And so pre-hygiene and pre-sanitation measures, infants were exposed really, really early in life to the polio virus. And when infants were exposed, they developed this sort of mild GI illness. However, with hygiene and sanitation, you suddenly had children being exposed later and later in life. And this later exposure coincided with more serious reactions to polio, including paralytic polio. And so in the midst of the Cold War, in the midst of our post-World War II success, people had this really blind faith in the American scientific system, and they were convinced that this polio vaccine could be made. And so through a Herculean effort of a ton of scientists, Salk, who gets the credit, created this inactivated polio vaccine. And in 1954, he conducted a placebo-controlled trial with 1.6 million children around the world. And the trial went really, really well. It was found that his vaccine was safe and effective, and there was no evidence that linked the vaccine and polio. And so this was viewed as another huge success of Cold War America. This is great. We're the best. Let's get going. And so April 12th, the success of the vaccine was announced, and the very next day, it started to be vaccinated in the arms of first and second graders around the country. However, 2 weeks later, the first case of vaccine-associated paralytic polio was reported. The next day, on April 26, 5 more cases were reported. And it's important to note here that the American government and the Surgeon General reacted exactly how they're supposed to. Only 2 days after the first case of polio, the Surgeon General halted the use of the polio vaccine and created the poliomyelitis surveillance unit to try and figure out what was going on. And on May 7th, he suspended use of every single Salk polio vaccine until they'd thoroughly investigated all manufacturers and could figure out what was going on. And so in order to investigate the manufacturer's production of the vaccine, we first have to know how Salk made the vaccine. And so in order to produce Salk's vaccine, the polio virus was grown in kidney cells of monkeys. That's one thing I've realized doing this research is vaccine production is pretty gross. But so the polio virus was grown in these monkey kidney cells, and then the virus was inactivated with formalin, and then the virus was harvested via filtration. So this clearly worked really well for Salk. With 1.6 million children, he'd had no associated cases of polio. However, investigation of the manufacturer's production of the vaccine revealed a discrepancy between the way that Salk was producing the vaccine and the way the manufacturers did. See, during the filtration process, Salk used a very specific filter that filtered out clumps of virus and protein. And it was really important to filter out these clumps because the formalin couldn't fully penetrate these clumps. And so there was some active virus that still remained in the clumps. This filter was great. I mean, it worked really well, but it was really slow. And so the manufacturers had decided to swap the filter out for a much faster one that wasn't quite as effective at filtering the virus protein clumps. And so that resulted in some active virus entering the vaccines that were then being injected into children all over America. I've decided, this is a bold statement, but I'm putting it out there because this is my talk. I think that the Cutter incident marks the beginning of the modern anti-vaccine movement. This disaster was very real, and in many ways it was very old. I mean, here is an instance of what people were concerned about with the smallpox vaccine and what had happened with the smallpox vaccine of the vaccine causing the illness. But the effects on the American psyche were very new. As I said before, we were in this post-World War II Cold War America where we thought we were invincible and anything was possible. Additionally, it's really important to note that after World War II, we were still a very militarized country with a deep trust in our government and scientists. It was one of the rare times in our history as a country where we were primed to do things for the greater good without thinking of ourselves as individuals, because that was the patriotic thing to do. But the Cutter incident revealed the imperfections in the scientific process and often the selfish motivations of manufacturers. And so this primed Americans to be much more hesitant about new vaccines. So the Cutter incident laid the tinder for the modern anti-vaccine movement, but the DPT controversy in the 80s is really what lit the spark. The DPT, or the pertussis vaccine, which is whooping cough, was first invented in 1912. So it was actually one of the really early vaccines. In 1942, it was combined with diphtheria and tetanus to make the DPT vaccine. 2 years later, it was approved by the American Academy of Pediatrics, and it was incorporated into the regular schedule that millions of children were getting all around the country. So that was all fine and good until April 19th, 1982, when the documentary DPT Vaccine Roulette was broadcast across America. This documentary put concerned parents and sick children in one corner and the FDA, doctors, and vaccine manufacturers in another corner. It portrayed the government, the medical industry, and the vaccine industry as these money-hungry, selfish, uncaring individuals who were hurting children, and then these concerned parents were the heroes of the story who were desperately trying to figure out what was going on with their children. So this documentary claimed that the pertussis component of the DPT vaccine caused fever, collapse, inconsolable crying, convulsions, brain damage, encephalopathy, SIDS, intellectual disabilities, and even death. The question in this documentary was not, does the pertussis component cause brain damage, but rather how much brain damage does the pertussis component cause? This documentary depicted these vignettes of these heartbreaking parents and children, and these children were suffering from these really debilitating, ambiguous neurologic conditions. And the parents were convinced that these conditions were caused by the DPT vaccine. So this documentary and the aftermath of the documentary was really complicated because some things were true and others weren't. From the beginning, from 1912, when the whole cell pertussis vaccine was created, it was known to be an imperfect vaccine. As early as 1940, there was published literature that was documenting neurologic damage following the pertussis vaccine. Japan had viewed the risks associated with the pertussis vaccine unacceptable, and they were actually one of the first countries to develop and regularly use an acellular version of the vaccine, which is what we use today. But despite the risk, the US favored the vaccine largely because it was pretty cheap to produce and the effects were rare enough that they sort of took that in as a cost-risk analysis that they were willing to take. DTP vaccine roulette brought what had once been a conversation within the scientific community to the public, and it prompted many scientists to reevaluate the vaccine. In 1991, there was a committee from the Institute of Medicine who sort of did a mass analysis of all the studies and all the case reports on the pertussis component of DTP and the DPT vaccine to date. And these were their conclusions listed on the slide above. The committee did find that there was sufficient evidence to conclude that there was a known relation between the pertussis component of the DPT vaccine and acute encephalopathy, anaphylactic reactions, fever, crying, screaming, and this sort of hypotonic, hyper-responsive episode. But it's important to note that these were all very acute conditions and were not known to have long-term effects on children. The claims of SIDS, brain damage, intellectual disabilities were found to have no known association with the DPT vaccine. However, even though these were the conclusions of the scientists in the country, the anti-vaccination community didn't really care. And that's because young children and infant deaths were becoming increasingly rare. No longer was this kind of just a part of life that we could explain away as this really tragic thing that just happened. But parents wanted a reason for why their kid was disabled or dying, and they really weren't satisfied with that's just the way it is and we don't know. And so DPT vaccine roulette gave these parents the explanation that they were craving for why their child had died or why their child was disabled. And so that fundamentally changed the anti-vaccine rhetoric. And this was the first association we see between vaccination and neurologic disorders. And it also marks a fundamental change in patient advocacy as well. This documentary was published on the eve of the internet, but even so, parents actually called the station and they created phone trees of anti-vaccine parents, and they were able to spread narratives and stories and information, and that way build a really solid anti-vaccine movement. So with the connection between neurologic disorders and vaccines made, this really primed the world to be successful to Andrew Wakefield's research, which connected the MMR vaccine and autism. So in 1998, Andrew Wakefield, who was a gastroenterologist in the United Kingdom, and his colleagues, they published a study in The Lancet that investigated a supposed link between the trivalent MMR vaccine and autism. In Wakefield's paper, he took 12 children with chronic encephalitis and regressive developmental disorders. Of those 12 children, 8 of them had autism-like tendencies within 1 month of receiving the MMR vaccine. His hypothesis, which I've illustrated here, this is my favorite slide in the whole presentation, is that the MMR vaccine, specifically the measles component of the MMR vaccine, caused gut inflammation. And this inflammation resulted in the incomplete breakdown of food peptides. These peptides somehow crossed the blood-brain barrier and entered the brain. And in the brain, they caused neuroinflammation and resulted in subsequent autism. It's important to note here that despite several flaws we already see in his hypothesis, the neuroinflammation that he is citing is chronic versus the only proven neuroinflammation that we saw with the DPT vaccine was acute in nature. So there had never been a connection between chronic neuroinflammation and vaccination. So even without looking into Wakefield as an individual, there's some problems with this study. There were no controls. This was not a blinded study. There was no systemic data collection. The children were handpicked by Wakefield to allow him to create this seemingly strong link between gut inflammation and autism, which in reality were these very common conditions. And the worst part is that even though he handpicked these children, he did a really bad job at handpicking these children, because the GI symptoms that Wakefield was claiming to be the root of autism did not precede the diagnosis of autism in some of the children in his study, which completely invalidated his entire hypothesis. So looking at only the study itself, this should have never been published. And the outcry against this study was further exacerbation when more information was revealed about Wakefield as an individual. It turns out he altered the medical histories of the participants in the study to support the vaccine autism narrative. And additionally, he had a financial interest that he did not disclose in discrediting the MMR vaccine. So Wakefield's work here is the origin of the vaccine autism hypothesis. And this is one of the most common anti-vaccine arguments we hear today. This hypothesis has been modified over the last few decades. You don't really hear the gut-brain axis connection with neuroinflammation and autism as the primary hypothesis anymore, but it does persist as one of the most popular anti-vaccination theories. Like the DPT documentary, this sparked a media sensation. The documentary had primed the American people to be susceptible to the idea that vaccines cause brain damage, and Wakefield really just took that and ran with it. And so when thimerosal was proposed to cause neuroinflammation 2 years later, this was incredibly believable to the population at large, especially in the anti-vaccine community. And so it was really easy to make that shift in the anti-vaccine mind from gut inflammation causing autism to mercury causing autism. And so with thimerosal, in 1997, the FDA mandated that all mercury concentrations in food and drugs be available to the public. And so with that mandate, it came to light that infants were being exposed to 187 micrograms of mercury within the first 6 months of life due to vaccines. And this mercury, is important to note, was in the form of ethyl mercury, which is a component of thimerosal. Thimerosal is an additive in vaccines. It's been an additive since the 1930s as an antibacterial agent, and it's never been proven to cause any harm to patients. However, despite this lack of evidence of harm, thimerosal was proactively removed from vaccines in order to foster public interest or public trust in vaccines. Unfortunately, this proactive move actually had the opposite effect. It was viewed as many anti-vaxxers as an admission of guilt that thimerosal was harmful. And primed by Wakefield, it was really, really easy to believe that this different type of neuroinflammation was causing autism. People knew mercury was harmful and concluded that because thimerosal had mercury in it, it must also be harmful. And so this further fueled the vaccine autism narrative. So why do we care about vaccine disasters and safety and efficacy controversies? As I've discussed these last 45 minutes, some of these are very real, like the Cutter incident, and some are imagined, like thimerosal. And so why not just brush off thimerosal because it's irrelevant? And while it's because it's not irrelevant, each of these controversies, both real and imagined, have all provided fuel for the anti-vaccine movement. And so they're remembered in the fabric of our society. And it all goes back to this trust in the medical profession. It's earned and not finally given. And so if in order to facilitate these trusts, we have to acknowledge and have responses for things like thimerosal causes autism. And so I wanted to conclude this talk by just touching on a couple of the key anti-vaccine arguments we hear today. And these are not going to be things like vaccines are putting tracking chips into us. These are more of the vaccine hesitant parent arguments. And so the people that you would likely most see coming into your clinic or encountering in your medical experience. I think it's really, really important to be able to have responses to these anti-vaccine claims, because if somebody is coming to you with concerns about vaccines, but they're coming to you as a medical professional, it means they still trust you and they still trust your medical opinion. And so you have a really, really great opportunity here. Instead of sort of brushing someone off and brushing their concerns off as irrelevant or crazy or unimportant, this is a really valuable time to engage in an important conversation with them and show them where these theories come from and why they're not correct. And so, as we can see, things like vaccines cause autism, we see the clear root to that. The mandatory vaccination arguments we hear today, vaccine additives, hygiene and sanitation, the flu shot causes the flu. All of these arguments have their roots. A side note is that the arguments involving the immune system, I think, would require a completely separate talk and a completely separate paper, but those are very interesting and sort of related in the hygiene hypothesis that you see coming up in the mid 20th century to explain the rise of allergies in children. And so with that, I just wanted to thank everybody for coming to this talk. I especially wanted to thank Dr. Saunders, who's been my elective advisor and who has stuck with me through this 50-page paper. I wanted to thank Dr. Nekachea, Lorena, and the entire Bullitt History of Medicine Society. And I just want to thank everybody here for coming to this talk. I did not imagine this many people would be interested in hearing me speak, and it really means a lot to me that you're here. So thank you so much, and I'm happy to answer some questions if we have time. I'll stop sharing my screen too.
Yes, thank you so much for your really wonderful talk, Elizabeth. I think everyone found it really informative, and we already have some questions coming in. Everyone feel free to put your questions in the Q&A box if you have some for Elizabeth. Your first one is from Michaela Sullivan Fowler. She asked, did I hear you say that Mather's slaves, quote, taught him, end quote, about the smallpox variolation? Did they explain how they had been inoculated before traveling to America? Did they explain how the variolation administrators produced that smallpox agent? Can you say a little bit more about that?
Yeah, I'm happy to speak more about that. And so when Mathers was advocating for variolation, this wasn't the first time that variolation had entered America, basically. There were advocates in Europe as well. And so this was a known but controversial procedure at the time. So there was literature on it in Europe and in America as well. And so Mathers, from the research I read, Mathers originally learned about variolation from his slaves that he owned. And so he saw the scars and they explained to him that they had this procedure and that they now couldn't get smallpox. And so then he went and looked at the published literature that was in Europe. And so that further cemented his conclusion that variolation was something that was positive, and then he became an advocate for it.
Your second question is, can you expand on what philosophical exemptions for vaccines are? Maybe examples of what parents are saying to qualify for this exemption.
Yeah, so philosophical vaccines kind of cover the broad umbrella of I just don't want my kid to be vaccinated, which is one of the reasons why North Carolina doesn't list those as a justifiable reason for your kid to not be vaccinated. That's by far the loosest qualification we have for you to not be vaccinated. So that can be anything from I don't believe in vaccines, I think vaccines cause autism, I've done my own research. That's where it becomes much more subjective and much more personal. So there are basically, to sum it up in a very short sentence, philosophical exemptions are I just don't want my kid to be vaccinated. And so for obvious reasons, some states decide that that's not a good enough reason.
Okay, Andrew asks, what factors do you think will help/hinder efforts at widespread COVID-19 vaccination when one or more become available in regards to hesitancy?
Yeah, I actually debated including a bit on the COVID vaccine in this presentation, and then it turned into a black hole, so I decided not to. But the COVID vaccine and the conversation around the vaccine is really fascinating because when you look at past rhetoric on risk perception and vaccine hesitancy, the previous common knowledge has been that when the disease is low, like when smallpox the vaccine's working really well, but smallpox isn't that visible, then people become more skeptical and more hesitant of vaccines. But in the event of an epidemic or a pandemic, people become, anti-vaccination kind of drops and people become more willing to be vaccinated. We're not really seeing that during COVID. It seems to be that a lot of people are still it's past the vaccine hesitancy, and we're veering a lot more quickly into conspiracy theory territory and more widespread conspiracy theory territory. I think there's a lot of things that are contributing to that, especially the fact that people are at home more and isolated and on their computers. But I do think, so I think that that's a major hinder to the widespread uptake of the COVID vaccine is people are really isolated and now very selective on where they're getting their news from. And so if they're solely going to anti-vaccine websites, that can kind of be a really big rabbit hole for them. And so I also think that unfortunately, the messaging from the White House currently has been kind of mixed signals. They are very supportive of the vaccine, but they've kind of been sending mixed message on the seriousness of the pandemic. And so I'm hoping that with the new administration coming in, we can have a more solid front on taking this pandemic seriously and on the effectiveness and the trust in the vaccine. This is a long answer, but I'll just finish. I do have a personal problem oftentimes with how the surveys on anti-vaccination and COVID are done, because a lot of times the questions asked, like, if a vaccine was available today, would you take it? I'm like, I wouldn't take it today, like, no. And so I think that the anti-vaccination sentiment around the COVID vaccine can be a bit more overblown, just because the data isn't fully out yet. And like a lot of people aren't willing to take the vaccine until they know that it's safe. But there is that component, I think, of a more conspiratorial nature we haven't seen in the past.
Your next question is, can you speak to vaccine hesitancy for people of color?
Yeah, so I have a portion of this in my paper as well, but vaccine hesitancy for people of color is a very valid thing. There have been multiple times in human history where people of color, especially Black people in the United States, have been experimented on in the United States, and aside from vaccines, and then explicitly with vaccines as well. So there's one specific example where there was a vaccine that was tested in Haiti, and it was found to be unsafe, and yet people decided to test that. So that's its own problem to begin with. And then despite the fact that it was found to be not safe, it was tested again in Black and Latinx communities on children in the United States. And so there is a very long history of the American medical community experimenting on Black and Brown individuals, especially in relation to vaccines. And so this is a huge area where I think the medical community has to earn this trust back. This is not freely given, and it's justifiable for why it's not freely given. So we have a lot of work to do here.
Your next question is from Joanna Smith. She says, from what I've read, it sounds like there's a critical threshold where some people being unvaccinated threatens the effectiveness of a vaccine overall. Can you explain how this works?
Yeah, so this isn't really what my research focused on, so I hope I can still give you a satisfactory answer. But basically, I think it often depends both on how effective the vaccine is and the infectivity of the pathogen itself. And so like when we're talking with the COVID vaccine, they're saying that the Pfizer vaccine is 90% effective, and that's really great. And that would mean that for every 10 people who got the vaccine, it wouldn't work for one person. And so then the next question becomes, how detrimental is it for it to not work for that one person? And so that's where that like threshold kind of comes into play.
Great. So it looks like that is all the questions you have. But thank you so much for such a wonderful talk. I think everyone learned so much from it.
Awesome.
Thank you for attending.
Yeah. Bye. Have a great day.